Now let's take a look at the DS1000 series measurement capabilities. I'm going to turn off the digital filter on channel 1. And I'm also going to disable channel 2 just so we have a little bit more room on the display. We can measure two channels simultaneously. It's just a lot going on the screen for demonstration. So what we can do is hit the measure key. And we're going to measure channel 1. Now what I can do is I can hit display on, and that will bring up all of the measurements that I have capable or enabled on that particular channel. In this case we have Vmax, Vmin, Vpeak to peak, period, frequency, and a number of other measurement capabilities or measurements types for that waveform of interest on channel 1, which can be very useful. What I'd like to do now though is show you how to key in on a single type. Hit measurement again, then we'll hit display off, so all of those go away. But now let's go to time, and let's rotate down to frequency. Again, we can pick individual measurement types, both in the time and the voltage areas. But time, I'm going to select frequency, and then I'm also going to go to cursor, and I'm going to hit auto, and that's going to put the cursors on the screen in the position that we're actually taking the measurement. So if you have a particular, or if you have questions about where the measurement is being taken, you can enable the cursors and hit that auto mode, and that's going to align the cursors on the screen, and you'll be able to tell exactly where on that waveform that frequency measurement is going to be made. Now let's take a look at some of the other cursor measurement modes. Let's go to cursor, and then out of auto, let's go to track. And what tracking is going to do, as you can see, it's actually moving along with the signal. I've collapsed the menu for that particular function, but you can see as I rotate along, in this case I'm moving channel, or I'm moving the cursor, and the cursor actually has a time and as well as an X designation or cross there, and you can see it's following the waveform, so you're getting coordinates or locations on the waveform display based on the waveform itself. And so you can also see over here we're getting some measurement changes in delta X and delta Y corresponding to the position of that particular cursor. We can go back and highlight B, and that's going to allow us to move the second cursor, and we'll get that delta between those in both X and Y. If we wanted to do something a little more manual, we can go to the manual mode, and the manual mode is going to allow us to select either Y or the X-axis, and you can see they changed. Let's select A, so we can move cursor A and the X. We can move cursor A and the Y. See that? And we can also move both of them as a delta if we wanted to do fixed, or singly, which can again be useful if you were making some measurements on your waveform. Now let's take a look at the reference mode. So we're going to get rid of our measurements. We're just going to go up to cursor and all, and then let's disable our measurements as well. Clear. And now we just have channel 1. What I'd like to do is I press the reference. I'm going to actually grab a reference here, and you can select between channel 1 and channel 2 as long as channel 2 has been enabled, or math. We're going to stick with channel 1. Now let's do external. Actually, let's do internal, and let's hit save, and now you'll see that the reference waveform, and we'll just have to move it out of the way, the reference waveform is exactly like the waveform that we've captured here. You'll notice that it's also stopped. So it's taken a capture of a particular slice in time of that waveform as it's coming into the input, and it's replicated that here. And it can be manipulated just like a normal, it can be manipulated just like the regular waveform, in that we can raise it and lower it, and we can also shift it in time. That's useful if you have a particular waveform that you want to compare to another waveform. In this case, we could bring channel 2 in, compare that to channel 1's reference, or we could make some changes to our circuit and then compare that to channel 1 as well, or to that reference as well. Now let's take a closer look at some other functions that we have available to us. I'm going to disable reference, and I'm going to enable math. You'll see in Operate for the Math menu, we have a number of functions available: A plus B, A minus B, A times B, and then FFT. So we can do a fast Fourier transform analysis of that incoming waveform and break it down into its frequency components. Let's select FFT. Again, we can select channel 1, channel 2. We have different window options available to us. We're going to stay with rectangle. And we can split the view, so we can enable a larger screen display. We can also select dB VRMS, or we can go VRMS. And let's stick with that. Now you can see what we have now is we have frequency versus voltage, and I think you can make out some of these up here, some of the analysis of that particular waveform. Now let's just expand it a little bit, and we'll just go to the first three waveform, or the first three frequency components that we have available to us. And by pressing the horizontal key, we'll actually get that center frequency is located at 3 kilohertz. So this is the 3 kilohertz frequency. We can rotate it down and read the center. Now we have a peak at 1 kilohertz, which is our fundamental, a peak at 3 kilohertz, and then we have a peak at 5 and a peak at 7, etc., etc., which is what you'd expect from a square wave in an FFT, or in the FFT, or the frequency domain. Another great feature of the scope is the mask and pass-fail function. So I'm going to enable the scope to run again, disable math. I'm going to go to utility and pass-fail. And pass-fail is, sometimes you'll come up in this main page, page 1, you'll see it says 1 of 3. So let's go to 2 of 3 in the utilities menu. We'll hit pass-fail. And now what we can do is create a mask. So we can go up to mask. And we can actually set the number of divisions or percentage of the division that's going to be the X mask and the Y mask as well. So we'll make both of those 0.20 divisions. We can create that mask, but let's just get back up into the mask setting. So we can enable that test. Now you can see, by enabling the mask, we have basically put a framework around the incoming signal that says, okay, this is what's going to be a pass area. And then we can operate that. We can pick the source. We can turn the message display on, which is going to give us a number of fails, number of passes, and then the total number of waveforms. So we can operate that, and you can see that'll increment. And then if we go to a fail, now we have a number of lines that are outside of that original mask and setting. I'm going to just turn that off for a second, and also turn the stop on output, and we're going to have the output on fail. So that means that when it fails, the box is going to stop, and you'll see it will quit taking waveforms. So we've gone into stop mode, and now we've only had one fail, but that fail has stopped the instrument from taking any more data. It's also through the output on the back of the instrument, it's also disabled or sent a failed signal. We've configured it to do that by using the output fail, and then we can also do an output on pass if we'd like. So very flexible. You can set up the scope to run, for a long period of time, and you can check to see the number of waveforms that have passed or failed over a given period of time, which can be useful for troubleshooting some problematic signals.